Twinkle, twinkle, little star, how I wonder what you are. Knowing the life cycle of a star is important in understanding what stars are. Like everything in the universe, stars are also born. The life cycle of a star starts with a large cloud of gas and dust, also known as nebula. Nebula will gather together and eventually be pulled together by gravity. They all look so beautiful and colorful, like these pictures. Nebula would start to spin and heat up at the center or the core. This will cause the cloud of gas to have mass and begin to glow. Thus, a protostar is born. You must be thinking that this is the star that we see at night, but no, this is just the beginning. Protostar is just a young star. The young star would grow just like how you guys are still growing and accumulate more gas and dust. The core will continue to heat up and reach 15 million degrees Celsius. At this point, hydrogen gases in the core can fuse with themselves to become helium. This process is called nuclear fission, which will release heat and energy. At this stage, the star would stop growing. This is because the nuclear fission at the core of the star would push the star outward, but gravity will balance it and push it back in. This star is also known as the main sequence star. It would grow brightly for millions to billions of years. At one point, after billions of years, the hydrogen gases run out. From here, depending on the mass of the star could take on a different life path. A low-mass star like our Sun will have its outer layer expand and cool off and glow red. This is what's called as a red giant star. In the red giant's core, another nuclear fusion reaction happens where helium is fused into carbon. The core shrinks while the outer layer keeps expanding. When helium is also used up in the reaction, the star will be very unstable. The outer layer will expand until it's ejected to outer space. This phase is called the planetary nebula. However, it is not related to any planets. It is just called so because early scientists thought it looked like a planet through a telescope. Finally, all that's left is the core of the star, the white dwarf. It is white because it is still glowing and releasing stored energy. When the energy is all used up, it will cool off and leave a black dwarf. Sadly, this is the end for stars that has a low mass. On the other hand, a high-mass star, which is bigger, about 10 times or more the size of our Sun, will have a different life path. One example of a high-mass star is Betelgeuse. When hydrogen gases run out in the star's core, instead of expanding and cooling off like a low-mass star, another fusion reaction happens. The reaction is helium to carbon. Then another fusion reaction occurs to form another element. The reaction continues until the star has a core of iron. The star would be extremely big, which would be known as supergiant. At this point, the star can no longer undergo fusion reaction, hence there will be no energy left to balance with gravity. The outer layer of the star starts to rapidly collapse under the gravity until it reaches the iron core. Since it is so dense, the force would bounce off the core and cause a shockwave that will make the star explode. This is called as a supernova. Although it sounds horrifying, a supernova is not all bad. The energy and elements released from a supernova explosion can help to form new stars. Look at all these colorful pictures of remnants from a supernova. Can you see that they all look similar to nebula pictures that I showed earlier? The core of a large mass star, on the other hand, collapses down to form either a black hole or neutron star depending on the star's mass, and that is the end of life for high-mass stars. That is the life cycle of a star. Here is an image of a summary of everything. Thank you for staying and learning through the wondrous and beautiful journey of a star.